to all. We are gathering for to talk about the case study topic on PSLV C62 rocket launch happened in the previous week, January 12, from Sriharikota. But it was a failure. That is the thing we are going to discuss. So here we are being available with third year students, my mentees. They are going to discuss for what purpose the rocket launch was, then why the failure happened, then what are the learnings from the failure. So those things will be discussed from our student side. They will be going to expose their knowledge on this.
Today I will be giving a basic intro on the case study of PSLV C62 launch and also the failure. So it was held on Jan 12, 2026 in Sriharikota. PSLV, why PSLV in the sense? Because it is the launch is going to take place going to the LEO. So only like 15 satellites will be launching over there. The payloads will be like EOS N1, so it is the main one. So for them EOS in the sense it is New Space EOS N1 mission, so under New Space India Private Limited. So along with that there are 15 satellites. It is domestic and international space systems also will be going to that LEO. So what happened in the sense, PSLV is Polar Satellite Launch Vehicle, everyone knows, which is known as workhorse of ISRO, because it has high reliability and also for like the success rate is very high compared to the other launch vehicle. So even though it is like it's been like around 67 or 68 missions have carried over, but even though there is some failure occurs in that. So before that like C61 also made of the same failure around like third stage. So today our team will be discussing on that.
So good morning everyone, I am Gopika from third year aerospace engineering. So in this topic I am going to talk about the mission overview. So PSLV C62 mission was launched at Satish Dhawan Space Center at Sriharikota. The main goal of this mission was placed its payload in the correct orbit around the Earth. So it's the main goal of this mission. And the PSLV, in the initial stage of the mission, the liftoff and the early flight was performed normally as expected. So in the PSLV rockets, that has the several stages. So each stage produced the thrust from the specific parts of the flight. For the successful missions, so each part and every part works perfectly. Even a small problems in the propulsion controls or in the separation parts, it leads to or it affects the final results. Unfortunately, in the later phases of this missions meets the anomaly. So due to these issues, so the missions was not completed successfully.
Good morning everyone. I am Ardi from third year aerospace engineering. So let me describe about the failure event. During the flight of PSLV C62, an anomaly occurred during one of the critical stages, and that which leads to the mission failure. So as a result, the launch vehicle was unable to place the payload into a designated orbit. So while detailed investigation reports, ISRO confirmed that the mission was failed to achieve the planned goals. So usually these failures were occurred usually related to the problem of propulsion performance, stage ignition, navigation, guidance or control systems. So it is important to note that usually space missions involve extremely complex systems. So we know that even a minor deviations can lead to the whole mission loss. So that's it. Thank you.
Good morning everyone, I am Bhavya. I am here to explain the reason for this failure. Although the exact reason for this failure requires a post-flight analysis, they said it is due to the PS3 anomaly, a specific drop in the combustion chamber pressure which led to the loss of control and deviation from the flight path. This is not the first time. Similarly, a similar failure occurred in the last last year of May 2025 in the rocket stage 2, which is also due to the similar reason in the pressure drop of the combustion chamber.
Hello everyone, I am Janani from 3rd year Aerospace Engineering, and I am here to conclude. The PSLV C62 is a failure launched on Jan 12, 2026 explains that why space exploration is challenging, and even with decades of failures, even with the decades of experience, failures can occur. ISRO has a history of setbacks from failures and learned from that failures, and every time they overcame those failures with improved systems and better quality control. As in future aerospace engineers, we must not focus on our failures. We should see them as stepstones.
Yes, it's a nice contribution from our student side, I think so. Okay, it's a very nice contribution from our student side regarding the failure of PSLV C62, which happened 1 week earlier from the failure quota. They have studied all the things, but I want to know some discussion over the things because they have dealt about it's a very complex system in a rocket. So many things are there, like a payload as well as a combustion chamber. Pressure is a very important thing here. The pressure will give you the thrust. So the thrust is very important. More amount of gas out, that means mass out means it will produce more amount of thrust. As well as we can have other part that is called the pressure also. If you give more amount of pressure, the thrust will be increased. As well as velocity. Velocity is it comes under the momentum thrust. So mass flow rate, that is weight flow rate into the velocity. And one more thing, anyone can you say about what is called as specific impulse? Anyone?
So it is the efficiency of the performance of the rocket. So generally, so it is the formula is like thrust by weight flow rate.
Yeah.
Generally.
So it is very important. Okay, how much this propellant can be used perfectly. So in a rocket it is called efficiency point of view. If the specific impulse is high, okay, the thrust will be higher for the given weight flow rate. Okay, so specific impulse will reflect on the efficiency of a rocket. So those kind of things, basic parameters and all, we should know. Okay, what we have studied in the SI engines, as well as SI engines, as well as IC engines regarding the automobiles. Here we are studying about the rocket engines also. So those things very important, and the specific parameters are very available. With respect to the values, it reflects what parameter, whether it affects whether the thrust is increasing or decreasing based on values. Those things and all you have to be very careful, because in any interviews can be asked if this will be increased, what about the efficiency or what about thrust. Okay, if velocity is increasing, because we are going to have a nozzle here we are having CD nozzle. Why CD nozzle are used in rockets?
Because of more thrust. So comparatively, like well nozzle and aerospace nozzle, CD nozzle kind of thing will be have more convergent diversion. So more amount of pressure will be reduced, and at the particular time. After that, their velocity to increase the velocity. So
there will be a relation with respect to area with the velocity. Okay, area increases, what happens generally? Velocity will be reduced generally. Okay, if area is increasing, generally velocity will come down. That means both are inversely proportional. Okay, but here CD nozzle, one is convergent. So here the area will be going narrow down. So velocity will be increasing. And after a particular point of time, it will be divergent. Divergent means area is increasing, but we need more amount of thrust, so that we need more amount of velocity. I told you that if area is higher, what about the velocity? It will be coming down, but we need more amount of velocity. Okay, but here the rocket will go at a faster rate. So initially it will be subsonic, and it attains throughout sonic speed. After that, it will go into the supersonic speed. in supersonic, the area velocity ratio will be reversed. If area is going higher, the velocity will be also higher. So the velocity, more amount of velocity will be going to result in the more amount of thrust. So that CET analysis are very useful, and you have to know about this CET analysis about how the velocity will vary with respect to area. Okay, one side it is narrow, and another side it is divergent, but velocity also going on increasing only. Here the velocity will start to increase from the entry to exit. So, okay, so in subsonic it will behave reversely, and supersonic it will also reversed. Okay, so that point it is very important. That is called momentum thrust. Another one is called the pressure thrust. More amount of pressure will give you more amount of thrust also. Pressure into area, that will be pressure into area will be the force. That is the thrust first. Okay, so the combustion chamber pressure is also very critical factor in the failure of the PSLV C62. C62. Okay, we will have a nice discussion, and another discussion on another topic. Okay, thank you all.
Thank you.